cooling curve. What is cooling curve? Cooling curve means, I mean, whatever the state of a material that you are having. Suppose you are having solid state or liquid state or gaseous state. What is the thing that if you will try to extract the heat from there, okay, what will happen? Their temperature will reduce. Okay. Suppose if you can think about your refrigerator in your home, okay, what they do basically, they are extracting the heat from the source, okay, the or a refrigerator, refrigerator do, they extract the heat from them, and extracting the heat will cool down the object, right? So what they do, simply they extract the heat. So extracting the heat from the source or from the material, that will basically define your uh, that will define sorry, I distracted with the message. Okay, sorry. So extracting the heat from your source, okay, or from the material, that will cool down your material. Okay, but it depends up to what extent that you are extracting the heat, so that they are changing their phase. Okay, sometime what happen? It would, I mean, it change the. Take an example of the water. Okay, if you have water and you have kept in inside the refrigerator, what happened after some time? If you have kept in the freezer, so think of not in fridge. If you have kept in freezer, what happened? You see that your all water has converted into ice. Okay, so what happened? I mean, basically the refrigerator is extracting the heat from the source. Okay, so extracting the heat will cool down them, and up to certain point, up to certain temperature, they will be in their uh, uh, own phase or on original state. Like, I mean, they were like the water, so they would be water till certain temperature. I mean, up to that temperature, if you will extract the heat, that would be in their original form, means their liquid state. But if you would continuously extracting the heat, they will start to changing their phase. So that happen, and whenever the changing is happening, that is at a constant temperature. What constant temperature means? The temperature of that particular object will not change. Okay, suppose you have a water. Okay, you have water here. Okay, now you are in a bottle. Okay, now you are extracting the heat. You are taking the heat from this one. Okay, so they will try to cool down. Okay, but at certain temperature. Okay, that temperature is known as critical temperature. So at after the critical temperature, you will continue extracting the heat. This particular water will try to change into solid. So that solidification will occur at a constant temperature, because the amount of heat that you are extracting from the source, that is being continuously removed, and due to this particular action, the body in itself keeping maintain at a constant temperature. So keep in mind, whenever the phase changes occur, okay, phase changes occur, the material would have the same temperature. Okay, and if we think about, because when we are discussing the here temperature, it means obviously you have kept the pressure constant. Okay, so during the phase change, your temperature and pressure always remains constant. Keep in mind. Okay, so whenever the phase change occur, the temperature will and pressure will remain constant. So whatever the, I mean, whatever things is happening in our compression refrigerator, our pressure is our atmospheric pressure, which is throughout the environment is constant. Okay, which is 1 atm. And if we talk about the temperature, then if you are decreasing the temperature, your material is getting cooled down, and up to certain limit of temperature, they will cool down. But after that, the the material will change their phases, and that changing the phases will be happen at a constant temperature. It means you have kept the temperature at the beginning constant, and now you are having the constant temperature during the phase change. It means that whenever the phase changes occur, your temperature and pressure remains constant. Okay, so keep in mind. Now, just reverse of that. If you have kept the pressure constant, now you are providing the heat to the system or to the material. What will happen? Your material will firstly get heated. They will absorb the heat until that critical point. Okay, or up to a certain temperature. After that, if you are continuously supplying the heat, the material will start changing their phase. So the solid will convert it into the liquid. Okay, and that have changing the phase would also at the constant temperature. Okay, so constant temperature, constant temperature. When it doesn't matter, you are going from one to B, one to two, or two to A. I mean, it means solid to liquid or liquid to gas, or liquid to gas. Sorry, solid to liquid or liquid to solid, or liquid to gas or gas to solid. It doesn't matter. Whenever the phase changes occurs, okay, that would be at a constant temperature and constant pressure. Okay, so at that the certain point which is known as critical point. If you are keeping your water in your refrigerator or in your freezer basically, then at a certain point, the critical point of temperature, after that the material will change into the water will start changing into your solid. But all of the solid will not get converted into solid. All of the water will not converted into solid simultaneously. They will take little time. Okay, so during that time is known as your phase change. Okay, and that phase change is of your two phase system. Means the two phase coexist. I mean, they exist together. Okay, so during that, the phase change, you would see the material are having both a combination of the phases, which is solid and liquid. Both exist together. If we talk about the solid and gas only, solid and liquid only. If you are observing your system is like the liquid and gas, okay, then you would be seeing that you are having two phases together, which is a liquid and gases together. Reverse of that would be also possible. Okay, so think here. If you are having a pure metal, if you are pure metal, then what kind of the cooling curve that you will get? This is the your cooling curve. What means it? What does it mean? It means whenever you will extract the heat, because you are basically cooling the curve. Cooling curve means you are extracting the heat from the system so that the system will cool down. So whenever you are taking the heat, this is the time, right? So as your time increases, the heating rate will increase and the heat will come out. I mean, suppose you are extracting the heat at a constant rate. Constant means, I mean, whatever the amount of the heat is being extracted from the system is constant. They are not varying with the time. Okay, they are coming constant. But why this graph is showing this thing? Because as the time increases, the temperature decreases. Because in this sense, the temperature is increasing. So this particular graph shows that they are decreasing, and how they are decreasing. And after decreasing, I mean, decreasing means they will the temperature of that particular system or particular material will lower down, but up to this particular point B. Okay, so at certain point, which is known as your critical point. So at the critical point, what happen if you are extracting the heat again? Okay, or you continuously, or you are keeping extracting the heat from the source, it will change. It will start changing the phase. So this particular line is, as you can see, at B to C line is a constant. Why it is constant? Because at this point you are seeing the phase change. So whenever the phase change is occurring, you are having your constant temperature. Sorry. So this B to C line is your constant temperature line. It means you are having a phase change. But still, if you are, I mean, suppose you have reached here, C. What's C indicating? First, I mean, A is just a normal whatever the state of your, liquid is. Okay, so this is the A point. But if we talk about the B point is the critical point at which the liquid start changing into solid. Okay, if you are extracting the heat. So till point the C, I mean, this is the two phase region. Two phase region means both solid and liquid exist together. But at the C, what happened? All the liquid has converted into solid. Okay, so all the conversion of this liquid to solid has completed at point C. But what happened if you are extracting the heat still? Then it will lower down again. So this is your solid line, because at the point C, all the liquid has converted into solid, but at the B, you are basically started. The liquid had started converting into solid. So this B is a start point and C is the end point. But but if we talk about the A to B, this is a completely liquid line, and further after C, this is your solid line. Because what happened to the solid? The temperature of the solid is being decreased. As you can think about your refrigerator in not over the fridge but over the sorry, not over the freezer but rest all. So I mean, whatever the things that you, I mean, if you keep the water inside your fridge, they don't get converted into solid because you have kept the temperature till, I mean, they are basically not reaching this particular point. I mean, you are maintaining the temperature before the critical point of water. Okay, so whatever the critical point of the water is, that is being not reaching by the refrigerator, so that you are not getting your water converted into solid. So this is the idea how the cooling curve occurs. So this is the cooling curve. Simple means, I mean, the liquid will start decreasing their temperature, but till a certain point of temperature. After that, they will convert it into solid, and once they have converted all the liquid into the solid, they will decrease the temperature of solid. Okay, so they, I mean, if they are, I mean, in the form of solid, still they are having the different temperature. Like, I mean, when you have converted all the water, means you have made here ice. Okay, but after the ice, you could decrease the temperature of ice as well. So this is a decreased temperature, decreasing the temperature of ice. Okay, so this was this all idea about your pure solid. If the solid is there, and I have made you know, I know, don't know, but you can think about the pure. I mean, if we talk about the pure substance, the water is a pure substance. Okay, so keep in mind. So what is the best example of pure substance? Now we can think about the alloy. Okay, so what happened to the alloy? Okay, or alloy, or you can think about the binary solutions. Okay, so in alloy you are having, I mean, only two phases. Okay, sorry, two components. I mean, alloy of many kinds. Okay, you could have the more two or three or five. Okay, but what we are concerned here, we are concerned about only the two systems. I mean, there are the two components in that particular alloy. So in that sense, what happened till A to B, till A to B, you are having the same graph. It means they will, I mean, as long as you will extract the heat, they will cool down. But at B, I mean, B means the at critical point, and obvious, you cannot think. I mean, the critical point of this particular point at this particular material and this particular material have the same. This is kind of the indication. That's why we have kept this all line together so that you could have idea. But every binary mixtures, or or any other multi component systems would have their own critical temperature. Okay, as the pure substance, if we talk about the pure substance, every pure substance has their own uh, critical temperature and pressure. Okay, so we have just, for the comparison, we have kept B here. So till here you are basically having the same graph. Means whatever the things that you are basically, as long as you will extract the heat, the temperature will lower down. Okay, but as soon as they reach at the critical point or critical point of that particular binary system, they will changing their phase. Okay, how? You can see about, they are changing, but they are not linear. Okay, they are non-linear. Why they are not linear? As you can see here, it is linear, right? Sorry, constant, as a constant temperature. But you can think about, you can say, I mean, why they are not constant here? They are, why having some, because they are of having two systems. Okay, two component basically. The system of two component basically. System of two component means their phase changes will occur not simultaneously. Okay, not together. They are having different temperature. Suppose, I mean, you are having A element and B, right? So A and B together make a binary system. Okay, so these are the basically your basically alloy. Okay, so you can think about, if pure, then all the atomics, the atom will change their orientation together. Okay, at a particular temperature. But what about, I mean, suppose A have not, they have reached here, but after that, suppose A has not been converted, but B is being converted. So every material have their own critical point. Critical point means critical temperature and pressure. But if they both have mixed together, that would not be of same kind. That's why this graph is like this. Okay, but at particular temperature, the all material will converted. I mean, binary system will convert it into the solid, and till that you would have the same line. So after C, you have the same line, same graph as you can see. So I mean, B to C, you are having this different kind of, line, different kind of the graph basically. They are not linear, okay, or they are not like a linear relationship, okay. So this is the idea. We are extending the time, okay. Okay, so let me finish this one, okay. So I will, so this is for the mixture of other, which is known as multi-phase alloy. So this is the cooling curve of the binary solutions, as we have discussed in this particular things, okay. And this is your multi-phase. So what happened in multi-phase? Think about the multi-phase. I mean, they are having different elements. They are same till the B. Okay. So at B, they are basically start converting. But what happened? They are having the same curve as in a binary solution, as you can see. They have reached, but after C to D, they are having the different kind of, I mean, they are changing their phase till, at the constant temperature. As you can see here, this is a liquid and a solid because both exist together, okay. In the same sense, sorry, in the same sense as this particular graph, this particular line, this particular line, and this particular line, both curves are like same, okay. But in this there is one extra which is known as the constant phase, constant. As you can see, the constant line, constant temperature, and D to E are the same as here, C to D, C to D. Okay, this is the cooling curve. So once you understand the cooling curve, okay, then we can discuss the phase diagram. Okay.